All right, so I think this is recording. Let's take a look at these two problems. They are radical equations. We want to start out by isolating the radical and squaring each side, step by step, solving for x, and then making sure to check our solutions for extraneous solutions. These two problems are different, however. In number 4, I see two terms that have radicals in them, where in number 5, I only have a single term. So in number 4, I need to isolate one of these radicals. You know, I really don't have any kind of rule of thumb that would suggest to pick one radical over another one to isolate it. So if we take a look at number 4, I'm simply going to subtract the square root of x minus 1 from each side. So this first term, I'm going to leave it where it is. And over here, if I subtract the square root of x minus 1, this is what I have. So to get rid of this radical on the left, I'm going to square that. So I have to do the same thing on the right-hand side. Squaring something is an invertible operation. So in an equation, when you do that, you may introduce extraneous solutions. This resulting equation may not have the same solution set as the original equation. On the right-hand side, when you are squaring this binomial that has a radical, you may not have experience in doing that. Until you do get used to it, I suggest that you do it in the form of a table. That way it's nice and neat and organized, and you'll be less prone to silly type of mistakes. And it doesn't take that much extra time to make the table. 3 times 3 is 9. Then we have negative 3 times the square root of x minus 1. We have that same term twice. Negative times negative is positive, and the radical goes away. So now on the left-hand side, let's return to this equation. On the left-hand side, we have x plus 2. On the right-hand side, we can look within the body of this table and add like terms. Along this diagonal, we have the x, but then we have 9 minus 1, which is 8. And along the other diagonal, we can combine these two like terms to get minus 6 times the square root of x minus 1. We can subtract x from each side. Those terms cancel. Because see, now let's stop and look at what we have. Originally, we had an equation that had two radicals. And we isolated one of the radicals, squared both sides of the equation. The resulting equation, at first glance, you're like, boy, you haven't simplified anything. But yet we have, because this resulting equation only had one radical, whereas the original equation had two radicals. So it has been simplified. But the problem is we just still need to keep going. And the lucky thing is we don't have to change techniques. It's just repetitive. It's the same idea. We're going to isolate the radical, square both sides, just like we've been doing. So it's nothing within the problem that makes it harder. It's just simply that we have a longer solution here. All right, so let's subtract 8 from each side. 2 minus 8 is a negative 6. And I may as well divide each side by negative 6 so that I have 1 is equal to the square root of x minus 1. And if I square both sides of this equation, I'll get rid of the radical. And I have 1 is equal to x minus 1, so x has to equal 2. Now, I say x equals 2, but really I don't know if it does or not. That could be an extraneous solution. It's the only solution that I have to go with right now, so I need to check it. So if we do check that, what do we have? Well, so by substitution on the left-hand side of the original equation, instead of x plus 2, I write 2 plus 2. and then that's plus the square root of x minus 1, but instead of x minus 1, I write 2 minus 1. And the big question is will this arithmetic result in 3? So 2 plus 2 is 4, and the square root of 4, the principal square root of 4 is 2. And 2 minus 1 is 1. The principal square root of 1 is 1. And yes, it's true that 2 plus 1 is equal to 3. So this checks, and this is in my solution set. Now, let's take a look here at number 5. We're going to start out that the radical's already been isolated for us. So we're simply going to square each side of this equation. So when we square the left-hand side, the radical goes away, and I have x squared minus 3x minus 1, but you can't forget to square the right-hand side, and that's, believe it or not, easy to do, you know. Let's get this. It's also easy to not get this in standard form, to not have this equation equal to 0. So we have x squared minus 3x minus 10 is equal to 0. And this we can easily factor to x minus 5 and x plus 2. And this gives us possible solutions of positive 5 and negative 2. So we need to check these and see if either one of these is extraneous. Will they both satisfy the original equation? So when I plug in 5 on the left-hand side, I have the square root of 5 squared minus 3 times 5 minus 1. And the big question is, will that result in 3? So this is 25 minus 15, which is 10, and 10 minus 1 is 9, and the principal square root of 9 is 3. So yeah, that checks. So x equals 5 is in my solution set. All right, so let's take a look at negative 2. On the left-hand side, what do we get? Well, if we replace x with negative 2, we have negative 2 squared. And if you're keying that in a calculator, you need to have parentheses around that base. Otherwise, you're going to get the wrong answer. So the big question is does this result in 3? So what do we have here? Well, negative 2, that's 4. The negative times negative is positive. 4 plus 6 is 10. 10 minus 1 is 9, and the square root of 9 is 3. So this one also checks. So this one has 2 solutions, and we found them both. So I hope that helps, and I'll talk to you later. Bye.